Last but not least, because now we deal with stablecoins, the digital euro, and CBDCs. And that will also be the title of our first speaker of the last segment, Dr. Klaus Alfert of Zühlke Engineering. His topic is managing complexity, operating a CBDC. The stage is yours.
Yeah, thank you. Good evening all for this late evening session. I'm Klaus Alfert, I'm with Zühlke, and I talk about my recent project, which we did with our client GND, Zühlke Engineering, and they partnered together with central banks to build their national digital currencies. So GND is a well-known player in that field. If you are into security, technology, into payments, they come from banknote printing 170 years ago. And when they envisioned the future for the currency state, they came more or less obviously to the conclusion that for public currency, CBDC is the relevant topic. And we at Zühlke, we support them into achieving this vision, which is quite drastic. So, where are we? We at Zühlke, we are a service company helping our customers to design and implement their business ideas. We start early up and help them through the entire cycle from innovation to implementation and to operations. We are sitting here within Europe, but also in Asia. We are doing 60% of our business with banks and banking institutions, often helping these traditional players to move their business, for example, into the cloud, but we are also with very new companies there, and we are quite good at doing things for the very first time. And CBDC is exactly of that kind. So CBDC is a very new topic, at least from the maturity level. So in this world map from this summer, there are only very few currencies worldwide which are already in operation. So that's Nigeria, the biggest country, the others are the Bahamas and the Caribbean states. But every country else which is involved into that part, and that's roughly 110 of the 180 existing central banks, they are more or less in a development phase, in a research phase. Some are into pilots. So also the central banks have no real clue what they want to do, and it takes a lot of time to do that. And with our partner, with GND, we are involved in several of these pilots and several of these R&D projects. And what I tell you now is our experiences from that phase. So CBDC is a broad topic, and the requirements on that from the business level, they are quite conflicting. And if you think about providing a product which is in a space where you have many different and conflicting requirements, you have a huge product space where you need to define your position. And just to give you an indication of what kind of requirements we are talking here, we have something like wholesale CBDC, which is eventually nothing more than doing interbank transfer. So it's kind of a new implementation of the well-known and well-existing RTGS systems. It is rather boring. But when you go over to retail CBDC and want to make your currency available as a digital asset for each and everybody, so that everybody in your country can use it for everyday payments, it becomes vastly different. When you look into regulations, of course, AML and KYC, etc., this is really required, and the regulators at first all cry, we want to have full transparency, and you read it sometimes in the newspapers that introducing something like the digital euro results in that the central banks can see what we are all doing. But on the other hand, privacy is, in particular here in the Western states, the most important requirement at all. So trust into that system, that is a necessity that anybody will use it. And at the same time, you need also trust into the currency to achieve a stable currency. So this is of utmost importance. And you need somehow to balance transparency and privacy and trust to that area. And then you have online CBDC, which is nice for e-commerce and e-banking. That is usually based on accounts, and you need to be online to do it. And on the other hand, there's offline CBDC, where you can pay everywhere, even without access to the internet. So you can also pay in the trains of Deutsche Bahn or somewhere in rural Africa or something like that. This requires, from the technology perspective, something completely different, which is usually token or bearer-based. And you need to think about how to set up your CBDC. And not to forget, since it's legal tender, it must be also reflected properly into the legal system, and typically it doesn't. So in parallel to the technology about the policy, you also need to derive new laws that support that. So it's really a venture how a CBDC project in a country moves on and in what direction exactly. Same applies for non-functional requirements. They are rather extreme. Yeah? So you need to provide something with high security. You are never allowed to get hacked. You are never allowed to lose any money anywhere. You need to provide a user experience and a usability which is easy to understand and enables also something like peer-to-peer transactions. We'll look into that a little bit later. We need high performance and high availability. A payment system like that must run 24/7. It's not allowed to stop. It's always on. Even when you update your systems, you must be able to pay anyhow. Yeah? And it must be, at least that's the experience that you want when you see it as a retail CBDC, you want it as quick and as final as you do it with cash payments. So it's not about doing an overnight transfer or something like that. When I want to buy my espresso, it must be done immediately. Buyers and sellers want exactly to have that. And it's a distributed system. Yeah? It runs in the entire currency zone. It runs not only at the central bank, it runs in all banks. It runs at all merchants. And of course, it must be interoperable with the existing payment infrastructure because it doesn't replace it. It's a new player on the game. So when I think about a system which is that complex, I see only dependencies everywhere. You don't see the forest for the trees. Nevertheless, you need to find a way through all of that. Yeah? So for example, consider this nice man here reminds me of my parent, my daddy, who's completely non-tech savvy, but of course he wants to pay with it. And he wants to give his granddaughter some money and wants to have it as easy as today. So picking out my wallet and just handing over a banknote. And I want to do that in the digital way as well. So something which is easy for me, like a PayPal application, that is more or less unfeasible for him. So we need something which is way more easy. But at the same time, we need a system which is also capable of securing me against state actors, because that's the big difference what you have from the security perspective to ordinary banking systems. So bank robbers are evil, but you can protect against them because you have a nice model what to do on your side to prevent them from doing something. But state actors, they have an unlimited budget. They are not interested in stealing money. It's enough if the economy is somewhat shaky, if you lose trust into the system. So corruption would be one important effect. We have ideas about that, which I, of course, cannot tell you here, but you need to balance, again, usability, you need to balance security so that this really fits. What we can, or where I can talk a little bit more about, that's another important aspect, that's the performance aspect. So it's not about defining a system which is as fast as possible. You need to find a system which is as fast as needed. So upfront, you need to think about what is my performance model? How fast must it be? And what fits nicely here is a model that says you need roughly 100 transactions in your overall system for 1 million inhabitants in your currency zone. So let's put that into a perspective. If you look at Swift, they are exactly nice for that because they produce every day a chart how many messages they produce and they operate on. So that's more or less all the institutional international bank transfer, and they're producing something like 39 million or 40 million messages per day. That is roughly in the ballpark of 450 to 500 transactions per second if they would operate 24/7, which I assume they don't do, at least not on every day. So it's perhaps they're doing something like 1,000 transactions per day. So that's their area. When we started 3 years ago, we started more or less, of course, with a blockchain-based approach. Yeah, the idea was let's put up a consortia of the central bank and various commercial banks, and they together define the truth about the system, and nobody can cheat in, and we somehow remove the right from the central bank to fool around with the money which I as an ordinary customer has. So that's a nice privacy statement. But you can choose any kind of blockchain you want. You have always a negative scaling effect. It's not unlimited, definitively not. A system like Hyperledger with their consensus algorithm that maxes out at roughly 1,000 transactions per second, because the speed of light is somewhat limited and you need to send many, many messages between all the participants, and that requires time. Our system at that time, what we implemented, runs at roughly 100 or something like that, because that's what's running on my notebook. And then the first customer comes along and told us, hey, you have a cool solution, we like it really, the offline capabilities you have and all that stuff, but we only go on further with you if you can scale up to 5,000 transactions per second. Steady pace, not fast pace, but really that steady pace throughout the time. And we had to think about how to handle that. And it was quite obvious. Hyperledger was definitely not the case, and we researched the blockchain market at that time, and we came to the conclusion, no, we need to be more radical, and we need to rethink our approach and our system. So we did the blockchain because we thought we need a trust relationship between the central bank and the commercial banks, but, sorry, that was the wrong slide. Nevertheless, the model about the speed seems to be quite heavily. So a country like Canada requires something like 4,000 transactions, Germany 8,000, just derived from the mathematics. And for the digital euro, it would mean you would need a system which scales up to 40,000 transactions. And if you compare that to what SWIFT is currently operating on, that's really tiny. Yeah, so they are doing perhaps 10% of all the payments that a mid-sized country like Canada does. So that's just to compare these figures. But back to what did we do at that time? So we knew now the requirements that where our customer comes along and said, yes, this is real, this is a sensible approach. We thought we need to trust the central bank anyhow. If you have a currency, you have no longer the gold standard for many, many decades, so it's trust only what you have which defines the value of a currency. You need the trust anchor of the central bank, and if you do that, you don't need a blockchain for that. Of course, we need some kind of operations to ensure that no double spending occurs and things like that, but that can be done from the technology space differently. And we switched the system to a relational database and could easily scale it up to 6,000 transactions, so getting at the barrier what our customer wants. And we have other technologies in place, like a distributed database, which we could driven our little experiments up to 13,000 transactions, and we know that we can scale it up by a factor of 10, even more, so 100,000 transactions per second, definitively possible to an ordinary price. So this changes how we put the technology in our system. It reshapes our system, and we needed to rethink the entire system. And with that approach, we could go into pilots, into real-world pilots. We have run several of them now, where we learn how the public uses that product. So where we interact with central banks, with some commercial banks, with end users which are using offline tools, which are using online tools to payments. So we have merchants equipped with proper devices so that we have really real-world use cases, how the public uses this new form of currency. And that is then the general way we do to manage this kind of complexity. It's about, again and again, questioning the requirements and asking you, okay, is my model, what I had in my mind when I designed it firsthand, is that really the truth, or does it fit? And from answering that part, you need to question and rethink your system. And sometimes you really need to go back to first principles and need to fundamentally think about how is my system set up and what are the major assumptions which I have in my architecture, in my system approach. And sometimes I need to change them, as we have seen with removing the trust from a consortium back to a central institution. And then you do proper engineering and refine the system and repeat that cycle. Because there's nobody in the world who can exactly say how in 5 years from now CBDC will look like, because nobody has done this before. So nobody can tell you how to do it, and you can ask nobody, how do you set up, how do you implement, how do you operate a CBT? That's our approach, what we do. And with that, we achieve that we can manage a CBDC, because a single payment, that's simple, but this vast and huge distributed system, that is complex, but you can manage it systematically if you approach it in a way I've just shown you. Thank you.
Thank you, Klaus.
Welcome.
We would have the time for a few questions if there are any in the audience. Yeah, there are actually two. That's nice.
Thank you for the presentation. It was really great. My question is, did you consider other DLT technologies for CBDC instead of blockchain before switching to relational database or distributed databases?
Yeah, we researched a lot. I've never read in my entire IT career such many research papers than in that project roughly 2 years ago, because we wanted really to understand, is there something which brings us the tech to scale up in a broad range and brings also the finality. So it's nice to have something which scales up, but it takes an hour that the consensus really works, so that simply the time you need for a transaction is utterly long, so that's really bad. You need to have it fast. Otherwise, if you tap at the supermarket and you don't know, is it really through or not, nobody will use it. Easy. Yeah, so you need to compete with something like a credit card transaction or something like that. And there's nothing, at least at that time, we found nothing which we find reliable in doing.
All right. Then I think back there was a question as well.
Thank you. You've shown that you can scale the whole program to a lot more transactions per second. Would those transactions have a transaction fee? Because if not, would it maybe be possible as a foreign country to attack the system by just spamming it with transactions that are for free somehow, just back and forth, and you would make up the cap and you can no longer use your currency?
Yeah, that's a difficult question. From the technology side, we don't build them. But it depends, of course, what the regulations and the policies in the country are. That's definitely up to the central bank to define or to set this up. From the more technical side, we definitely need to prevent our system against DDoS attacks and things like that. There might happen. At least state actors will for sure do that. And they don't need to have lots of money for doing that, because you can do 1 cent payments or something like that for sure. Yeah.
All right, we have one question in the Telegram group that is how do you deal with blockchains and the technology also around your solution constantly updating and evolving?
Yeah, that's an interesting thing. Upgradability is a complex topic. Starting with that we have many, many different technologies. So we have tiny devices running on a secure element where it's questionable if they are upgradable at all. So they have somewhat a limited lifetime of 2 years or something like that. They need to be exchanged anyhow. Then there are server-based systems running on internal clouds or something like that, and you can use all the existing cloud technology which is able to update the software on the systems while still running. That is generally true, but of course this must be engineered very carefully, because you can easily do nasty mistakes which then shake down the entire payment infrastructure of a whole nation. You don't want to do that.
You better don't. All right. Thank you very much.
Thank you.
Klaus Alfert from Zühlke Engineering. Please give it up one more time.